Today I am here to represent the topic number system. So what is number system? Firstly, we have to know about number system. Number system is a way to represent numbers in different forms. Yet how we can represent number in different forms? So there are how many types of number systems? There are 4 types of number system. First, binary number system. Second, decimal number system. Third, octal number system. And fourth, hexadecimal number system. So first one is binary. What is binary? Binary includes only bits, that is 0 and 1. Binary includes bits 0 or 1. Decimal. Decimal is, normally we are using decimal numbers in maths, in normal. So decimal is, that is, deci means 10, 0 to 9. Octal. Octa means 8, 0 to 7. And hexadecimal. Hexadecimal is a combination of hexa, that is 6, and decimal, that is 10. That means total is 16, that is 0 to 15. Binary is 0 and 1, so there are only 2 bits. So its base is 2. Base is also known as radix. Base is also known as radix. What is this? This is the total number of bits or digits present in the particular number system. Means in case of binary, there are only 2 bits, 0 and 1. So its base is 2. In case of decimal, there are 10 digits, 0 to 9. So its base is 10. And in case of octal number system, total number of digits is 8. That is 0 to 7. So its base is 8. In case of hexadecimal, it is 0 to 15. As I have already told, hexa plus decimal means it is a combination of decimal, number system and hexa. So this 0 to 15, we can say in this 0 to 9 is as a decimal and 10 to 15. For 10 to 15, we have to use alphabets A to F. 0 to 9 simply as a decimal number, and for 10 to 15 we have to use alphabets A to F. Means 10 for A, 11 B, 12 C, 13 D, 14 E and 15 F. Clear? These are the 4 types of number system. Now I am saying that in case of binary we are using bits. So firstly we have to know about bits. What is bit? Bit is the smallest unit. That is a single unit. That is either 0 or 1. And combination of bits. Next one is nibble. Nibble is combination of 4 bits. That may be all 0, that may be all 1, and that may be combination of 0 or 1. The next is byte. Byte is a combination of group of 8 bits or 2 nibbles. because in one number there are 4 bits. So in byte 8 bit means 2 numbers. So it is a combination of 8 bits, means value in the form of 1 and 0. Then word. It is a combination of 16 bits. 16 bits forms word. So it is a combination of 1 and 0. But total number of bits is 16. This is the basic about bits. Now, these are the types of number system. How we can represent, how we identify that the given value, whatever here is given, which type of value it is. It belongs to which number system. Here we have to write the base of the number system. Means 1101. It can be binary, it can be decimal, it can be octal, it can be hexa, because it is 0 1 only. But if we write here 2, that means it belongs to binary number system. Similarly, 349. This belongs to decimal number system because here base is 10, that means decimal. Now we have to convert one number system into another. One thing more I want to discuss with you. Suppose if we have any value, this is a binary value, normally we consider it binary. But in this case, the digit at the right is LSB and the digit at the leftmost bit is MSB. Now what is this MSB and what is this LSB? LSB is least significant bit. And MSB is most significant bit. MSB and LSB. Most significant bit and least significant bit. These are according to their weights, which we can see at the time of conversion. So now, start with conversion. Conversion. So first is binary to decimal. Binary to decimal. Binary. This is the binary value. Its base is 2, and we have to convert it into decimal. So how we can convert it into decimal? The base of binary is 2. So starting with the LSB, with this bit 1 into base of this binary is 2 raised to power 0. We have to use this base with powers in increasing order. Then plus next bit 1 into 2 raised to power 1. Here 0, then 1. Plus next bit 0 into base 2 power 2. Plus next bit 1 into 2 raised to power 3. We have to use base 2 with increasing order powers for the conversion of binary to decimal. We don't have to use this base. We have to use another base. Now we have to multiply this. 1 into 2 raised to power 3. 2 raised to power 3 means we have to multiply 2 3 times. 2 into 2 into 2. 2 2s are 4 2s are 8. Plus 0 into 2 raised to power 2 is simply 2 raised to power 2. That is 4. Plus 1 into 2 raised to power 1 means 2. Plus 1 into 2 raised to power 0. 2 raised to power 0 means any number having 0 power is 1. So 2 raised to power 0 is 1. Now solve it. 1 into 8, 8. 0 into 4, 0. 1 into 2, 2. Plus 1 into 1, 1. Now add 8 plus 2 plus 1 is 11. And this is decimal number system. So we are using conversion from binary to decimal. Similarly, if we have value in decimal numbers, means binary value with decimal with point here. Now, how we can convert it into decimal? Same procedure. Before point means from here. We have to use same procedure like this. So 1 into 2 raised to power 0 plus next 1 into 2 raised to power 1 plus 0 into 2 raised to power 2 plus 1 into 2 raised to power 3. Now, after point, we have to use plus only. We don't put any point here. Plus this 1. Now power should be in negative. Here power, increasing power should be in positive. But after point, the power should be negative. So 2 raised to power minus 1 plus next 1 into 2 raised to power minus 2. Now same way multiply. 1 into 2 raised to power 3 is 8. 1 into 8, 8. 2 raised to power 2, 4 into 0, 0. 2 raised to power 1, 2 into 1, 2. 2 raised to power 0, 0. 2 raised to power 0 means 1. 1 into 1, 1. Now negative power. In case of negative power means 2 raised to power minus 1. When negative power is there, then we have to use it as a reciprocal, means 1 by. So 2 raised to power 1 is 1. Sorry, 2 raised to power 1 is 2 and it is negative power. So we have to use here 1 by 2. Plus 1 into 2 raised to power minus 2 is 1 by 4. Because 2 raised to power 2 is 4, then it is negative, that is 1 by 4. Now 8 plus 2 plus 1 is 11. 1 into 1 by 2. 1 by 2 is 0.5. And 1 into 1 by 4 is 1 by 4. That is 0.25. That means now add these 11 point 0.5 and 0.25 is 75. This is the decimal value. So next, this is binary to decimal conversion. Now decimal to binary. binary. This is a decimal, which means its base is 10. And we have to convert it into binary, so its base is 2. I already told you that we don't have to use this base 10. We have to use another base, that is 2. So in case of binary to decimal, we are using multiplication. But in case of decimal to binary, we have to use division. So before point, we have to use separate terms. Before point and after point. So before point means there is only 13. So we have to divide by 2. 2 6 are 12. So its remainder is 1. Then again divided by 2. 2 3 are 6. Remainder 0. Again divided by 2. 2 1s are 2. Remainder 1. Now this one, the one this is less than 2. So we can't divide it again by 2. So we have to use this one here. Because this value is less than the 2. So we have to put this value here in answer. And we have to use from down to top. That means the value of 13 in binary is 1101. But here point value is also mentioned, then that is 0.23. Now after point, to solve this value, we have to multiply this value by 2. Because we are using binary, decimal to binary. So multiply it by 2. 2 3s are 6. 2 2s are 4. That is 0.46. Now the value before point, that means this 0, is for answer. And the value after point, we have to use it again for multiplication. Repeat this multiplication again. 2 6 are 12. 1 carry, 2 4s are 8 and 1 9. Again before point is answer. After point we have to use it again. Again multiply by 2. 2 2s are 4. 2 9s are 18. That means 1.8. Now again this one is for answer and 0.84. Again multiply 0.84 by 2. That is 2 4s are 8. 2 8s are 16. That is 1.6. This one is for answer. We have to repeat these steps 3 to 4 times. So now this answer is from top to bottom. Now put this answer, put point and then this answer. This is the binary value for 13.23. This is binary to decimal and decimal to binary conversion. Okay, so next is decimal to octal. Same case as decimal to binary. This is a decimal value and we have to convert it into octal. So same process as we have converted decimal into binary. There we are using base for binary number system, but here we have to use base octal number system. So before point, the process is divided by the base of other number system. Here other is 8. So we have to divide it by 8. So 8 5s are 40. 3 is remaining. Then 3 2 32. 8 4s are 32. That is remainder is 0. Then again divided by 8. 8 6 are 48. Remainder 6. Now this 6 is smaller than this 8. So we can't divide it by 8, but we have to put this 6 in the answer. Our answer is from bottom to top. And similarly, after point 0.27 multiplied by 8. 8 7s are 56. 5 carry, 8 2s are 16 and 5 21. So it is 2.16. So 2 is for answer and then 0.16 again multiplied by 8. 8 6 are 48. 4 carry, 8 1s are 8 and 4 12. 1.28. So 1 is for answer and 0.28 again multiply by 8. 8 8s are 64. 6 carry. 8 2s are 16 and 6 22. That is 2.24. This 2 is for answer. Now this is from top to bottom. So final answer is 660.212. This is decimal to octal conversion. Next, octal to decimal. Octal to decimal is same as binary to decimal. There we are using base of binary, but here we have to use the base of octal. This is octal number system. Now, same process starting with 7. Multiply with the base of this octal number system in powers with increasing order. 8 raised to power 0 plus 2 into 8 raised to power 1 plus 8 raised to power 2. Then after point, the power should be negative. 8 raised to power minus 1. Now multiply 8 square. 8 square means 8 into 8. That is 64. 2. 8 raised to power 1 is 8. 7. 8 raised to power 0. Number having 0 power is 1. Then 4 into 8 raised to power minus 1 means 1 by 8. So 4 2s are 8. That means 1 by 2. Now 3 into 64. 12, 192. Plus 2 8s 16. 7 into 1, 7. Plus 1 into 1 by 2 is 1 by 2. That is 0.5. Now add. 2 1 6, 8 and 7, 15. 1 8 10, 1 11. 1 carry. 2 1 5 point This is the decimal number system. So next is decimal to hexa conversion. Decimal to hexadecimal. The same process which we are using for decimal to binary, decimal to octal. Here we have to use the base 16. So from starting before point it's 439. So divided by 16. 16 twos are 32. Now remainder is 11. So its total is 119. So in table of 16 you have to check 119. So 16 5s are 80, 16 6s are 96. Then 16 7s are, that is 112. And the remainder is 7. Again divided by 16. 16 ones are 16. Remainder 11. Now this one is less than 16. So we can't divide it. So we have to use this one for answer. Now this answer is from bottom to top. And I have already told you that in case of hexadecimal number system, values from 10 to 15. Values from 10 to 15 are represented by using alphabets. 10 for A, 11 for B. So this 11 is B. That means our answer is 1B 7. And then after point, that is 0.53 into 16. 16 threes are 48. 4 16 fives are 80 and 4 84. Now this 8 is for answer and multiply 0.48 again by 16. So it is a greater value, so you can just do it 2 times only. Eight 16 का 128. So 8 12 carry and 16 fours are 64 and 12 76. That is 7.68. This 7 is for answer. Now answer from top to bottom. So final answer is 1B7.87. This is decimal to hexadecimal conversion. So next is hexadecimal to decimal. Means 8, 4, C, 0.8. This is hexadecimal and we have to convert it into decimal. Now this hexadecimal means here we have alphabets. Now we have to figure out A is 10 and C is 12. So same procedure as in case of binary to decimal, octal to decimal and hexa to decimal. Base we have to use is for, in this case we have to use hexadecimal base, that is 16. Now same procedure, C into 16 raised to power 0 plus 4 into 16 raised to power 1 plus A into 16 raised to power 2. Then plus after point 8 into 16 raised to power minus 1. A is 10, 16 into 16 is 256, 4 into 16 raised to power 1 is 16, C is 12, 16 raised to power 0 is 1, plus 8, 16 raised to power minus 1 means 1 by 16. So divided 8 to the 16. Now multiply. 10 into 256 is 2560 plus 4 into 16 64 plus 12 into 1 12 plus 1 into 1 by 2 is 0.5. Now add 2560 plus 64 plus 12, that is 12 and 1 13, 2636.5. This is decimal value. Okay, that's enough for today. Then we will continue it in next lecture. Thank you.